So I wanted to talk about quasars in this video because I literally was true story. I was at Trader Joe's grocery shopping and I saw our quasar bar and I was like, oh my gosh, have to talk about quasars to everybody. So I'm gonna open this and then I'm gonna talk to you a little bit about quasars. Let's see if this is just as good as a billion times the mass of our sun. Well, this is what it looks like inside. It's like nougat and caramel. So, that's pretty good. Quasars. So quasar is actually short for quasi-stellar radio source. So it actually, when it was first observed before the Hubble Space Telescope, astronomers thought it was a star and that it was emitting radio waves because it seemed to be acting like a star. But by the time Hubble came around, they were able to really observe what was being emitted from these stellar, similar-looking objects, and they were emitting not only radio waves, they were also emitting visible wavelengths, ultraviolet, infrared, gamma rays, and microwaves. And they were like, "What is going on with these objects?" And when they would measure it, they'd find that there would be over like 10 billion the amount of energy coming from it than anything else in the universe, which went to show that it had to have been by a supermassive black hole. Now, supermassive black holes are what's always in the center of galaxies. There's other black holes, stellar black holes, regular black holes. Those are found more like mixed inside the galaxy, but in the center is normally a supermassive black hole. Or also an active galactic nucleus. So quasars are also referred to as an active galactic nucleus. It's such a fun word, active galactic nucleus. And what that just means is a galactic, because it's a galaxy, it's the nucleus, which means it's the center, and it's active, as in it's like currently emitting stuff from it. So quasars actually feed off of black holes, supermassive black holes, and because as you guys know, black holes are regions in space where their gravity is just so strong that they're just attracting everything in its path towards its, I guess it's a hungry stomach and it's gobbling up all the stars. Okay, it's so cheesy, but it's pretty much light can't escape because it's such a strong gravity. But we can get into Hawking radiation another time and talk about that. But for now, quasars. So quasars emit so much more energy than anything else in our universe. It can emit from like millions to billions, even trillions, the amount of electron volts than all the stars combined in the galaxy. It emits a lot more than even 100 normal galaxies combined. So it's a super luminous, super bright object, but they're also the most distant in our universe that we've actually been able to observe. Out of all the objects that have been observed through the Hubble Space Telescope and other space telescopes, quasars are the most distant. So to me that's really interesting, is you think the most distant, and the way that our universe kind of works is you're not necessarily looking back in time, but you are kind of like time traveling a bit, because the objects that you're looking at, like the light that by the time it got to us left that object millions of light years. That's where a light year comes from, millions of years ago. So anything that we look at right now, like the light coming from our sun, took about 8 minutes for it to get here. So the photons you're collecting on your skin when you're laying out on the beach, that left the sun 8 minutes ago. So really, really crazy, funky stuff. Also, what's like super interesting is so stellar black holes, they're usually around 10 to 100 solar masses. And what I mean by a solar mass is literally the mass of our sun, which is about 2 times 10 to the 30 kilograms. That's like really, really long for me to write all those zeros, so I don't think I'm gonna do that. But it's pretty massive, and with supermassive black holes, they're usually anywhere from 1 million to 1 billion times more massive than our sun, so about 1 billion solar masses of our sun. So these objects, quasars, are just such powerful objects in the universe. I mean, you can just imagine what some of the numbers I've been shooting out at you guys. So quasars are pretty funny objects, and honestly, I'm pretty full just from one bite of this thing, because I just scarfed down a burrito. So it happened after the gym. And yeah, so I say that this is pretty accurately named, this chocolate bar. But yeah. Alright, so I guess the last thing I'm going to leave off with you guys is tomorrow I'm so excited, I'm actually going to be joining as a host on the Tomorrow Show on YouTube, where I'm normally a host for their science show, but I'm actually going to be joining on them with the space show that they've had. That was the very, very first one that they actually created on the Tomorrow Show, is Tomorrow Space, which covers all the rocket launches that are pretty much happening around the world. And so I'm actually going to be joining them on that. I'm like really, really excited tomorrow. And there's going to be a rocket launch. It's going to be the Falcon 9 we're launching the Paz satellite, which is from Spain. It's from Madrid, Spain. And that's going to be launching from Vandenberg Sunday morning. It was supposed to be tomorrow morning at 6. I forgot when it's going to be Sunday. But yeah, so exciting news. And I will talk to you guys soon. Bye!